Explorations. Probing global diversification. We travel the world so you don't have to. Okay, we're here today to talk about comets and meteor showers and how they relate to each other, because there is a meteor shower coming up very soon. So let's first of all, I guess, start with the concept of the comet. Tell us about comets, how they come into being, and how they affect the Earth.
Well, comet is generally considered as a rubble pile of rocks and ice and a lot of frozen gases in there. They're formed from the early part of the solar system. Back in the early days of the formation of the solar system, you have these material accumulated into various sizes and masses. We get planets, and then the leftover debris they form into asteroids, and some of them form into comet. And then when they come close to, say, big planets like Jupiter, Saturn, Uranus, and Neptune, they get ejected to the far reaches of the solar system, and where the temperature is a lot colder. So all that ice can stay on the comet, remain intact. And so a comet is what astronomers consider as a pristine object.
You say the comets are essentially kicked out. What do you mean by that? Is it the gravitational pull, say, of Jupiter that would sling them into outer space?
That's right. If a comet goes too close to Jupiter, then the gravity of Jupiter would give the comet a boost in velocity and change the direction of travel. And by doing that, then it can actually kick the planet out to the furthest part of the solar system. Or the reverse of that is it could redirect the comet towards the inner part of the solar system. And in some cases, actually, the comet gets too close to Jupiter, then it would actually get captured and slam into Jupiter.
So comets, do you think that they were, from what I understand, were at least partly responsible for life on this planet? In other words, they sort of acted as space seeds, if you will. I don't know if I'm using a correct analogy or not, but maybe life as we know it was formed here because of seeding from outside sources like a comet.
That is plausible, because up until now, with all the advance of technology and sort of crossing the various disciplines of science investigation, we still don't really know how life came up on Earth. We do know that life depends on water. The life that we know of depends on water, and also all life forms on Earth, they have carbon, hydrogen, oxygen, and nitrogen. Okay, these are the four basic ingredients of life. These chemical elements, they are found in comets. So, and in fact, in the early history of the Earth, say before 2 billion years old, there was not a whole lot of carbon on the planet. And where did that carbon come from then? Perhaps then they came from asteroid and comet impact with the Earth, and that left us more carbon, and also altered the condition on Earth to allow the planet to start storing carbon then. So this is an ongoing investigation that sort of requires multidisciplinary investigation.
So just homing in specifically then on what a comet is, if you were to go out there, be able to go and see.
So in the early part of the solar system, we had a lot of debris, small debris flying around. They either get slammed onto planets or Jupiter. These large planets, Jupiter, Saturn, Uranus, Neptune, the gravity would push these asteroids and comet into a specific area in the solar system. So in the case of a comet, then, when they encounter these planets, they settle in two main areas that astronomers know of. One is called the Kuiper Belt, which is beyond Neptune and Pluto. Now, Now, astronomers use a specific distance measurement term called astronomical unit. Now, because it's becoming inconvenient to express distance in kilometers when the distance is so great from planet to planet. Basically, one astronomical unit is the average distance between the Earth and the Sun. And so using that as a standard yardstick, then, the furthest planet, Neptune, is 30 astronomical unit. Pluto is at average distance of 39.5 astronomical unit, AU. So Kuiper Belt is somewhere from 30 to 50 astronomical units, and the comet sort of sits in a belt, and it doesn't deviate far from the plane of the solar system. What I mean by that is, if you were to draw a picture of the planet, draw a circle, a line representing the orbit of the planet, all 8 planets, they sort of more or less sit on a piece of paper. Same with the Kuiper Belt comet, they reside on the same piece of paper, more or less. So from there, these comets would just stay there most of the time until they get perturbed by some gravitational forces, which, and I have to say, I don't know what that force is. Could be just comet passing close enough to each other, or come into some kind of interaction with even a very distant interaction, a gravitational interaction with Neptune, let's say. So that would propel them, change the direction, and they start, instead of just orbiting around the sun in the Kuiper Belt, they would start to make an elongated orbit and go towards the inner part of the solar system. And most of those comets, in general, they have a orbital period, which means the time it takes to circle around the sun once, under 200 years. So that's one reservoir of comet. The other reservoir is called the Oort cloud, and that's much further away. It could be extend as far as 50,000 astronomical units from the sun. At that distance, then, basically the sun's gravity is just have enough pull to hang on to this comet. So when the sun, the entire solar system, is traveling about the center of the Milky Way, when the solar system come close to another star, or say a giant molecular gas cloud out there, that's enough gravitational perturbation to push one of these comets from the Oort cloud to fall towards the inner part of the solar system. And those comets tend to have an orbital period of greater than 200 years, and some of them would just make one pass, swing by the sun, and get kicked out of the solar system for good. Would never come back then. So we have these two main reservoirs of comet.
So let's talk about this meteor shower coming up. There's obviously, from what I've read, a relationship between comets and meteor showers. Tell us about that.
Right. Typically, a meteor shower comes from a comet. When a comet comes towards the inner part of the solar system, it receives more heating and radiation from the sun, and so all that frozen ice and the frozen gases, it starts to turn into gas. It goes directly from solid to gas, and what we call sublimation. Okay, this is a proper term for changing a phase from a solid to gas. And in that process, the comet acts up and start to eject dust particle, and also the gas comes out as a broad tail that's always pointing away from the sun. So the tail that we see in the night sky, typically the broad tail that we see, is usually gases. Now, the dust particle is also ejected from a comet, and all that dust particles, they stay along the orbit of the comet. So when the Earth comes close to it, the gravitational pull of the Earth would draw these dust particles, and the dust particles from a comet would fall into the Earth's atmosphere. They're very small. The biggest one typically is only the size of a green pea, and they'll completely disintegrate in the upper atmosphere, about, I say, 70 to 100 kilometers above the Earth's surface. And we see that disintegration as a flash of light that we call meteor. The improper name is called shooting star, but then everybody refers to it because it's just like a bright streak of light, shoot across the sky then. So that's how we get a meteor. And if we run into a stream of this dust debris from a comet, then we get an increased rate of meteors in the sky over a small period of time, and we call that a meteor shower then.
So this particular meteor shower that's coming up, is there a name for it? I know you hear Perseid and these
Right.
kinds of names. I noticed there was like a bunch of numbers. I was trying to find the name of it. Is there a name that they're calling
Th-
this?
yeah, this one coming up the morning of May 24th. It's never been seen before, or at least we will never notice it. What happened is the comet was only discovered 10 years ago in a sky survey, and looking at and this comet orbits the sun roughly a little over 5 years. So over this 10-year period, and astronomers notice study the activity of the comet, and notice that perhaps this comet has been in this present orbit as far back as at least 1800s, and they look at they make certain assumptions about the production rate of dust and gas, and they say, okay, in one of the passages around the sun in the 1800s, the comet might have left a debris stream that the Earth actually would run through it the morning of May 24th. So we potentially would have a new meteor shower. And meteor shower is named after the apparent point of origin in the sky. Now, when you mentioned about Perseus, that means the meteors appear to have come from the constellation Perseus. For this one, the meteor appears to have come from the faint constellation called it's the giraffe. I'm trying to try to pronounce the name Camelopardalis.
Okay,
That's
better
the
you
giraffe.
than me.
Well, this is the faint constellation in between the Big and Little Dipper. Not prominent at all, so a lot of people don't notice it. So we should be able to see meteors coming from the northern part of the sky. Astronomers think the Earth will cross the debris stream between 2 and 4 a.m. Eastern Daylight Time, May 24th. And the best place on the planet to see it is North America.
Is there any chance that meteor showers such as this can bring us any harm?
No, because most of these dust particles would burn up disintegrate in the upper atmosphere. For this particular one, okay, I should say that forecasting meteor shower is still in its infancy. Particularly, this is a new comet. We have very little observational history of the comet. So the forecast might be off, or the show might be a complete flop. Now they think the best part of the show is between 2 and 4 a.m. Eastern Time. Potentially, we could get up to 200 meteors per hour.
When you say flop, then you mean that basically you won't see anything or very little.
Well, you could be just standing out there, for 2 hours, 2-3 hours, and you only see maybe 10, 20 in that whole duration. So
Does the moon affect the meteor shower at all?
maybe the effect on the moon might be more like the moonlight would wash out the fainter meteors.
So it'd
So
be a visual thing more than
that's right.
anything.
But the moon would be in a crescent form on that day, and wouldn't be a big factor. Moonlight interference would not be a big factor.
Now, how far are we along in the technology, the ability to, say, blast a comet or asteroid out of the sky, should it be approaching Earth directly? Can we land? Are the bodies big enough that we can land on a comet, for instance, as well?
It's actually quite challenging to land a spacecraft on a comet because comet is small. Typically, they might be 1 to 5 kilometer in radius, in diameter. The bigger ones might be 10 to 20, and a really big one could be like 40 to 50. These are the typical numbers. Of course,
How difficult is it? The speed of the comet, does it make it difficult to stay with it or to potentially land on it?
it's the small size of the comet that makes
Okay.
it difficult because the gravitational pull of comet is very weak. Uh, let's say if you try to land a spacecraft on the planet, and if you could do, if the lander does not go down at a slow enough speed, then if it bounces off the surface, then bounce, it will go up, and then that's it. The comet would not capture the lander again. The gravitational pull is very weak on a comet, so European Space Agency is having a very ambitious mission to study a comet that is already in target in its camera. New pictures released in the last few weeks shows the comet has started to develop a tail. So it's starting to develop activities as the comet makes a closer approach to the sun. And this comet sort of comes to slightly beyond the orbit of the Earth as its closest separation with the sun. So this mission is called Rosetta mission, and it has taken the spacecraft 10 years on a very complex trajectory to reach the comet. It is making a final approach to the comet so that sometime this month it would settle in a formation flight with the comet at some distance. So once Rosetta has set up a formation flight with the comet, then it's going to start slow down and go and use another complex set of maneuvers to lower the spacecraft towards the comet, and by August it would actually go into orbit around the comet. Once it has developed that orbit around the comet, then it will start to make observations of the surface of the planet using a camera and other scientific instrument to measure the physical and chemical properties of the comet, maybe its electrical and magnetic environment around the comet. Then it would try to deploy a lander called Philae, and that would land on the surface of Rosetta of the comet in November. It's a very interesting operation, again because of the very low gravity of the comet. So to basically, Philae would have to go descend onto the surface very slowly, and once it touches down on the surface, then it would shoot out anchors to anchor itself onto the comet. Then over time, then it would start deploy a drill and drill into the inside of the comet, extract samples, deliver it onto the mini lab on the lander to do scientific analysis. Now, this whole mission is going to last until December 2015. Now, the comet is going to make a closest approach to the sun in August next year. So then, what that means is the Rosetta mission is going to study the comet for a little over a year, just to see how solar radiation interacts with the comet material. But during this whole time, because the comet is ejecting gas and dust particle, it's a dangerous environment. One of these particles could disable the entire spacecraft.
What do you think? Do you think that the mission will have success?
I hope so, because this is very exciting. We've never seen a spacecraft sort of flying information with a comet, study a comet up close, seeing all the, not just the surface details, but the activities, and particularly in this case, the Philae lander. Once it landed on the comet, then it's going to take a series of panorama. Now, of course, we've never seen any view from the surface of a comet. It would be very interesting. There might be geysers of gas and dust coming off the surface. Nobody knows what it looks like. So we're hoping that this mission will be a successful, and we get pictures that we've never seen before. The morning of May 24th, whether there is a meteor shower or not, it'll be fun just to go out to look for these meteors. You don't need any equipment to see meteors. The best equipment is your own eyes. The apparent point of origin of these meteors is between the Big and Little Dipper, which is fairly easy to find in the northern part of the sky. So maybe bring a lawn chair out, a sleeping bag. It can still be very cold at this time of the year, and make yourself comfortable. If you look towards the north end, the meteor streak will be shorter. If you look away from the north, say northeast, northwest, you see a meteor making a longer streak in the sky. Again, we don't know the rate of the meteor. We don't know how bright they are. But until you look, you're going to miss out the show.
Yeah, I'm certainly looking forward to it. I always enjoy meteor showers. It's exciting. I mean, even to see one, you know, actually one is more exciting because you don't expect it. If you're in the middle of a meteor shower, there are probably a few that come down, but